Welcome to our webinar, again on leadership, achieving general artificial intelligence for better or for worse, featuring Dr. Richard Sutton at the University of Alberta, father of reinforcement learning and well-regarded author of the Alberta Plan, which has been drafted to understand intelligence that some view as it would be the greatest achievement in human history. So I welcome Richard Sutton, who gave a sterling presentation this morning to the DAMA Conference that we've recorded. And that's the presentation that I'll actually draw on and show to you. And along the way, I'll interrupt it from time to time as I see questions emerging, Rich, on an assumption that you're available to answer questions here and there. So let me bring the video up.
Okay, so main theme that I will be presenting today is to ask you to think about computation and intelligence separately. So these are the take-home ideas. Number one, we are living in the time of exponentially accelerating computation, and this leads to a second industrial revolution. This is the first great disruptive event that's going on now. But going on in parallel at the same time is this: we're entering the time of exponentially accelerating intelligence. This is a little bit slower, is a little bit not less advanced, but this, I think, will also lead to great transformation of humanity and the next great age of the universe, really grandiose things. And so there are two disruptions that are coming at us. One is just due to computation, and one is follows from that as we understand ourselves. So these two transformations are closely related, and we can confuse them easily. We can blur the distinction. It's important for us not to confuse them, but to be aware of both of them. So what is the difference between the intelligence and computation? Well, intelligence is basically computation together with the goals, the purpose, and the agency of a separate AI system. Okay, so these are the take-home ideas, and let me just build up each one of these and try to have it make sense. So first, the exponentially accelerating computation. This, in some sense, something we're all very familiar with. We're all very familiar with Moore's law, the fact that computer power per dollar increases exponentially. It's been going on for close to 100 years, and there is no end in sight. So there's roughly a doubling of computer power per dollar every 2 years. This is going on for 8 decades, at least. So this means that anything based on computation becomes 10 times more valuable every 5 years. And the cumulative effect of this over the decades is tremendous. So this creates a powerful, persistent pressure for automation. So what you are all experiencing is that computers are becoming much more important. Automation is becoming much more important. And this is just the story of our time. We are living through this time in which technological progress has made computation possible and dramatically increasing. So, and it leads, I think, to where we are, which is in the middle of sort of a second industrial revolution. First industrial revolution was the physical power of machines substituting that power in people and in animals. And the second industrial revolution, where the computational power of machines substitute for that, that's usually provided by people. So this means computation for things like perception, or for motor control, or prediction, decision-making, optimization, possibilities. So until now, people have been our cheapest source of computation, but now machines are starting to provide greater and cheaper computation. So that's the first dramatic thing that's happening right now. And it's a revolution. It's going to be disruptive. And it's a big thing. It leads to some of the recent milestone successes. Going back to a dozen years, remember Jeopardy? It was computers beat the best human players at Jeopardy. And then ongoing in this last decade, neural networks, artificial neural networks has transformed speech recognition, vision, and natural language processing, greatly improved the performance of all those systems. Large language models are particularly prominent now. enormous progress, enormous new capabilities, new tools, generative AI, generating images, deep reinforcement learning, my favorite topic. We've had uh, great improvements in various games such as Atari and chess, and poker and Go, race car driving, many of these things done without game-specific knowledge. Self-driving cars are gradually becoming a reality. AlphaFold is the thing that's figured out the three-dimensional structure of proteins. They've done that for every protein known to man. All these great successes are part of this um, revolution in computation. So AI, what do we call AI? AI has become like a buzzword. It's almost, we don't even remember that it's just two words. It has the word intelligence in it and artificial intelligence. But no, AI is just one word, and it means advanced computers or something like that. What does it mean? Yeah. So if we look around, just like I went to the drugstore the other day and I saw that toothbrushes have AI in them nowadays. It's true. Like not just this brand, but multiple brands. Um, what does that mean? That means it doesn't mean it can think. It does mean that it has sensation and it can sense some things. It can measure some things. It can make decisions. Not just toothbrushes, but also like washing machines would have are advertised as having AI in them. This is LG, the washing machine. Yeah. This goes way back, like in many decades ago, when the computers were first coming out, they would have intelligent terminals. And terminal was called intelligent if it had like multiple fonts in it, or could show things in two different colors. Um, so in all these, AI has cachet. Every producer of a product, a software product, hardware product, wants to say that their product has intelligence in it because it's cool. And so there's always been this push, and this causes sort of you could say an extension of the terminology beyond what it might normally mean. And we have to understand that this pressure will always be there, and that's what we're seeing now when every product is called AI. Um, so I think we have to be a little bit more analytical and think about is there a difference between just using computation and having intelligence? Okay, so um, here's another example. This is AlphaFold, the protein prediction thing. Really big deal. Really useful tool. Really transforming biology, parts of biology, and it does use things that are called machine learning, like deep learning, but it's not like natural intelligence in any way. It doesn't act, doesn't um, it doesn't make decisions. It doesn't have a goal. It doesn't feel pain or pleasure. Um, um, it doesn't have a life. What it does is it takes a protein sequence and then makes predictions about how it folds up into a three-dimensional structure. So that is not like any kind of intelligence that we would see in the natural world. So how, one question is, what should we mean by the word intelligence? Intelligence is just a word, and we can mean anything we want by it. I don't really want to be pedantic about how words are used, but I do want us to have words available for saying all the important things that we need to say. We don't want to waste our words. We don't want to use our words in ways that make it hard to say. Well, what should we mean by the word intelligence? Um, so the field of AI has historically failed to define the word. Uh, that's not good. Um, so here's some things that people have said in AI. I asked a prominent AI researcher at Stanford, and he said, "Well, it's sort of philosophy. It's beyond my pay grade." Um, Often in AI, they would say intelligence is whatever people do, and we say they are intelligent. No, this is not good. This is not okay. A serious field needs to have a proper definition of its subject. So, how are we going to do better than this? Like, is there actually a proper definition of of the term in the field. Well, there is, if you look, you can find definitions. Um, let me put this one on the table. Intelligence is the most powerful phenomenon in the universe. So that's not a definition. Maybe it's a property. Let's just consider that for a second. Is intelligence the most powerful phenomenon in the universe, as Ray Kurzweil says? Is it more powerful than supernova or black holes? Um, is this? I think it does make sense that the fact that there are intelligent beings in the world and that they are going to influence the world, the universe, if we give them time. The supernova have had billions of years to develop and become powerful. We give intelligence time, a billion of years to live in this universe. Maybe intelligence will be moving around the stars and planets, and it's not unreasonable to think that given enough time, intelligence really will be the most powerful phenomenon in the universe. Okay, but if we look back at psychology, William James, original psychologist from the 1800s, when his major works came out, and he defined intelligence as attaining consistent ends by variable means. It means you change what you do to get what you want. And so this is the idea of a goal, purpose. And so now if we go up to modern times, the definition that I like, I find will be most helpful to us, is that intelligence is the computational part of the ability to achieve goals. So if we have a machine or an animal or a person that can achieve goals through its computations, then we say that it's intelligent. Now let's be a little bit. This is one definition, is that it's about goals, and another definition is that intelligence is about mimicking people. These are two competing views of how we should use the word intelligence. Okay, so we might say that AI seeks to reproduce the behavior that we would call intelligent because people. That's obviously mimicking people. The Turing test, the classic Turing test, is about behaving like a person. Supervised learning, we often ask the machine to label things the way a person would label, and we say that's what it means to be intelligent. And of course, large language models like ChatGPT, they are tasked to generate text like a person would generate text. So all of these are about mimicking people. It's not about achieving a goal, not about achieving a goal. So this is a different idea. We have two definitions of intelligence. One is people, and two is achieving goals. And so which is the right definition?
One of the things that's apparent in listening to you in your presentation and reading your background is that while computing science is what you're known for, the reality is your training was in the humanities. And what's very interesting is to see the blend of the two. It's like arts and engineering somehow crossing a bridge. Tell me a little bit about your history, your breadth of interest, because this is astounding how you found yourself into the world of artificial intelligence and understanding intelligence, going back to some of the early psychologists.
Well, thank you, Perry. Actually, I think of it as pretty straightforward. I've just always been interested in the mind, how the mind works, and like when I was in high school, heard about computers and heard computers be described as giant brains, and so I was fascinated by that we could have a mechanical brain, and so I learned a little bit about how to program computers, and then I was surprised that they were so simple, and so you had to tell them everything. A computer, when you program, you have to tell it every little thing that it does. And how could a system possibly be intelligent? How could it possibly be a mind if it had to follow such explicit instructions and everything that it did? And then I thought again, well, surely our brains, our minds, are physical systems, and they're just following the laws of physics and doing what they're programmed to do. And so there must be somehow that a programmed system could be capable of intelligence. And so with that thought, I was hooked to how a mind could be understood and could be made with technology to be everything that our minds are. That was the goal. And then when I went to school at Stanford, it was 1975 when I went to school, when I joined there. And it was not possible to major in computer science in 1975, at least not at Stanford, because although Stanford had a world-renowned computer science department, it was just a graduate department. You could, as an undergraduate, major in computing science. So if you're interested in AI, you had to you had to major in something else. And some people would major in math, some people would major in operations research. Another natural thing to me, particularly, it seemed natural to major in was psychology. So I majored in psychology. I learned about animal learning theory. I learned about all that the psychologists have thought about how our minds work. And I've always found that a very productive source of ideas, psychology. And it's really influenced all the work that I've done in the field of reinforcement learning in general. So I studied psychology as well as taking all the AI courses that were relevant at Stanford. And then I went on to study at the University of Massachusetts in Amherst, where I was able to more traditionally take basically a computing science degree for my PhD. But just to generally answer the question, I've always tried to learn in as broad a sense as possible about all the different fields that inform us as we try to understand our minds. So I would take philosophy, I'd take biology, I'd take all the basic sciences. And now I'm guessing all the people in this room, you try to read widely. And I often read many diverse books about people thinking about how the mind works. It's something that we should always be doing throughout our lives, continuing to learn.
I was reading recently that the humanities are falling out of favor at universities, either because of the demand of students that are more immediately interested in a job and don't think that the humanities provides ease of access. But it seems to me in a world where automation and machines are increasing in their role of our lives, that we need people who have been couched in philosophy and in the values that these machines are going to have as an impact, particularly in the realm of artificial intelligence.
And I would certainly agree. And all that humanities background, philosophy, psychology, linguistics, and all the related areas help us understand the mind, help us deal with the changes that happen and understand them and think about our role in them and our role in the universe moving forward. I think that's all really important. I would like to see more of that. At Amy and at the university, we have a program of fellows, and we have been trying to broaden that beyond computing science to include, for example, philosophy, and bring in experts and new fellows, AI fellows that have their background in other areas who relate to artificial intelligence.
I took some notes from your presentation. We can simulate some of it. You got into a discussion, and I remember the word ridiculous, where we began to talk about the power of automation and the power of the super intelligent robots and the speculation that someday human beings will be subservient and slaves. You used the word, quote, ridiculous. Let's elaborate. Provide some defense for why it is you're of the view that somehow man and mankind will remain superior in the face of super intelligent robots.
Let's make it a discussion. I mean, is mankind perfect? Do we really represent the ultimate goal and limit of how beings should be, or are we imperfect and usefully subject to improvements? So the way we're perfectly imperfect is that we can recognize our imperfections and strive to improve. And so this is what I think mankind has always done for thousands of years, and in recent years by scientific means. tried to understand the way our minds work, and we've tried to form tools and improve ourselves. And I think this is just another instance. It's just a continuation of that pattern and that desire that we want to understand our minds, and the minds that could be, and we try to improve our mind and create offspring, in a sense, mind children. Yeah, I think it would be a good thing if we were able to make minds that were superior to our current minds.
But the perfect mind is the mind presumably that doesn't carry any uncertainty or doubt, and that is certainly alien to learning. I mean, learning and reinforcement learning is all about learning from a mistake and improving and getting better. So continuous learning, and what we as mankind presumably are doing in our evolution, is we improve as a byproduct of making mistakes. If the robot is claimed to be super intelligent, doesn't make mistakes, it seems to me that's not particularly smart, because they're not going to be learning anymore. They somehow believe they've got perfect knowledge. And I'm not, that's where I would throw my argument on the table of why the super intelligent, never making a mistake robot may not be as smart as the human being that actually makes a mistake, which takes you into the principles of uncertainty from physics.
But let me just agree that the perfect mind is not the mind that knows everything, because the whole point of mind is intelligence knowing everything, or is intelligence the ability to learn more, and of course the ability to learn even the basic things. Like an intelligent child is one who can play with the blocks and build up an understanding of the world efficiently and powerfully. So I want to say what I mean by intelligence, just a word. Of course, we mean whatever we want to mean by it. But what I mean by the word is this ability to improve your knowledge, not the ability to have knowledge. And under that understanding, the perfect super intelligent robot would be the robot that can gather a greater understanding over time. If we adopt the point of view that real intelligence is efficiently and perfectly correcting your knowledge, then we're embracing the idea that the knowledge will be wrong or incorrect at various points in times, and that's normal. And so perfection is not never making mistakes, but just correcting your mistakes as quickly and efficiently as possible.
So do we
Now,
build?
I want to say one more thing about this, if I may, sort of meta thing about it, which is that this actually is a major debate within the field. Like the point of view I'm presenting, that's saying intelligence is basically innovation and acquiring knowledge. It's almost a minority point of view. Many people would say, I want a smart system that already knows everything. So, like Chat GPT, for example, or the Chat, its successors. Those are systems that know a lot, and they've gathered a lot from the internet, and but when they exist after they're built, after they're released into the world, they no longer learn. They absolutely do not learn at all, and so I consider it ridiculous to offer those as an example of intelligence, because they don't learn at all, and they can't acquire knowledge, they can't correct their errors. They're only sort of smart because they're mimicking people, and people are smart.
Are those that are doing the coding appreciative of the fact that they need to insert doubt into their algorithms? That's a serious question. I mean, it seems to me what we're talking about is you don't want perfect. You always want to be aware of what is imperfect, because there is your opportunity for learning and improvement. But if your algorithm is after perfection, as you said, it's over. We're not making any progress from that point. So I think the algorithm,
as you might imagine,
go ahead.
As you might imagine, there are lots of different people doing AI in different ways, and some of them actually are building in doubt, and some of them are also trying to create a system without doubt that's just always right.
So this isn't, I mean, look, we're outsiders. Your opportunity to talk to you is to raise questions that we raise in the bar over a beer, but have no idea what reality is as to what the coding is. So you're telling me that this is a subject of discussion within the field of whether or not you should be bringing doubt into the algorithm so we can see continuous improvement, which for someone who understands reinforcement learning, that would seem to me to be why you are so well renowned. Either you were the first, or you've made the point that this is essential for achieving artificial general intelligence. So I guess we say thank you. Greg, you had a question or a point. If you don't, make one up.
When I look at AI, I really look at the ability of a human being through an algorithm or through a tool like a chat, something generative AI, to access some collective intelligence that I don't possess. So just in an example, I met with an executive director of a recovery center here in Calgary, and they have a $500,000 hole in their budget. And in about 90 seconds, I wrote a prompt to write me a fund development plan, a highly engaging 3,000-word fund development plan for this not-for-profit to raise $500,000 by December 31st, 2023. In another 90 seconds, I wrote a prompt saying, give me a 300-word summary of that center's inspirational key messages. And in that time, and plus, about an hour reviewing both of those documents, copy, paste, I gave them better key messages than they had themselves, and a fund development plan that my nationally recognized Association of Fundraising Professionals raised. So if I can access that kind of collective intelligence in under 30 seconds and generate something I had no competency to do, so that idea of accessing collective intelligence.
You say you spent an hour reviewing the documents and
Editing.
verifying that.
No,
Yeah.
editing it and making it my own. American Idol, take it and make it your own.
So I don't think it's correct to talk, 30 seconds or 90 seconds. It took an hour.
That was the
And
problem.
which is,
But ChatGPT gave me probably an 8 or 9 out of 10 in 17 seconds.
yeah,
So-
but it really, the difference between the 8 and the 10 is the hour. And I don't know, I just don't want to exaggerate. Obviously, it was extremely useful to you, and obviously many people are finding ChatGPT a really useful tool for creating text. And there's no doubt that it's really important. As you say, it's accessing the intelligence of all those people. But Google itself, of course, is a really useful tool. It's not creating anything.
We're using the word creativity. It's occurred twice now, and I was going to raise this later. Later on in your presentation, you talk about the new age, the age of life, where machines which are passive and inorganic are increasingly behaving as if they are alive. And you saw the future as the age of life. We've talked about it, the age of creativity. How do you distinguish between the two? And is there grounds here for discussion, or are you right and we're wrong? Or can we blend the two?
Well, just let's start correcting what you said, because I said this. We could call the one age the age of life. It's the age where we have life, and we have trees. And if we look around the world, the most important things are living things. And the next phase maybe is the phase of, you could call the phase of machines. But I also said that I wasn't really happy calling one life and one machines. And so as I struggled for a better term, I ended up calling, the reason that life and machines are not good is because our machines are becoming much more lifelike. And the reason machines are not good, or the reason life is not so good, because we more and more we think of living things as machines, as biological machines. So I think calling one alive and the other one machine is not a good terminology. And so the terminology I settled on I think what makes life, the key thing about living things is that they are replicators. They can reproduce themselves, and they can do that without understanding how they work. Like you can make a child, you don't understand how the child works biomechanically, you don't understand how the child's mind works, but you can make a new child and you can raise it up and it can be as smart as you or smarter. Whereas when we have machines, there is every machine exists first in the mind of a person, and then before it exists in the world. Whereas the replicated people, they don't exist in the minds of any and even of any person. They have this ability to just reproduce themselves.
Mhm.
So I call the one the age of replicators, and the other I call the age of design, because these the new beings, they exist first in the mind of some person, and then they exist in the normal world. And further, we might expect if we had AI, the AI could also invent new things in their minds and have them exist in the world. And so more and more, the things that exist in the world will be things that existed first in the minds first in minds. And so even buildings exist first in minds, and then they come into reality. Buildings and cars and technology, all those things exist first in the minds of people, and then they exist in the real world. Very much unlike replicators.
So this is where we were arguing that world that you're describing as a world of creativity.
Well, so the world of the replicators, it certainly involves creativity. But I would think that the age of design systems would also involve creativity.
Okay. I've got one other question. Then I'm going to ask you to tell us a little bit about the Alberta Plan. And that other question is deep fake. You made reference to the fact that there is grounds for being anxious about some of the usage, that people are applying to generative AI. Tell me a little bit about whether or not we should really be nervous. I see Biden watched a movie and has now got a artificial intelligence committee together in the US because he saw a movie that scared the daylights out of him, but so be it. So tell me a little about deepfake. Should we be worried?
I think we should not be scared, but we should be paying attention. And we every time there is new things, we have to adjust to them. So there was not that long ago, we had Photoshop and digital pictures, and we all had to get used to. You can't trust a photograph; it could easily have been faked, and now we are quite used to it. Well, this is just the same thing will happen with fakes, and the answer to deep fakes, I think, will be provenance, and this will be established cryptographically. So that when you receive an image or a video or any kind of information, you just have to have it'll be digitally signed by whoever is certifying in some sense when they produce it, they sign it, and then when you receive it, you'll see who the signer is, and if the signer is someone you trust, maybe the signer is the New York Times, and you may trust it for that reason or distrust it for that reason. I'm not sure. But you will be able to keep score if they provide something that is not that turns out not to be true. You will discredit their reputation from it. So I think it'll all work with provenance establishment, which can be done cryptographically. It's not commonly done, but it is actually not difficult to do, and it's absolutely secure. You can know who was the producer and certifier of that image or video.
The government's been a little bit slow on the uptake. I mean, this is the 100 million users a year ago, and now 1 billion today, are certainly overwhelming the capacity of government to regulate where the excesses are. But we see committees beginning to form. We see people nervous about free speech being compromised. But I guess that's the world that we're in. Is government is more reactive than proactive.
I think I have the opposite perspective. I think government is being too eager to regulate these things that they don't understand, first of all, and secondly, they're not stable yet. the things that they're regulating are things that don't really exist in any clear form. And so I think all the regulation you see now, we will see as extremely counterproductive over time. It's in many ways, it's a classic case of regulatory capture, where the big companies go in and establish the regulations that work to their advantage and rule out new entrants into the field.
Yeah, I was just going to say, I just read a really good article by Ben Thompson at Stratechery, where he describes that exact issue and how the apprehension that is being voiced by so many of the big players is actually having the effect of constraining the small players. It's actually limiting competition and solidifying the position of the big players in this entire field. So, and he was basically echoing what you were just saying, that the government is lurching into this without really understanding what they're up against and what they're getting involved in. And they may be being played by some of the big players. So, but anyways, that wasn't my question. I just wanted to pick up on that. I wanted to ask, and I think you've touched on it a little bit. If you reflect, if you're sitting alone in your house late in the evening and reflecting on the decades that you've spent in this field, and if you took a look back at everything prior to November of last year, and we're only a year since ChatGPT was introduced, and I'm wondering if you reflect on everything prior to November 28th last year and everything that's happened since. And what occurs to me is that when the media gets a hold of this and when it gets the kind of hype that we've seen over the past year, we often miss the point, the real point. And you made a comment about ChatGPT actually not being intelligent, and I happen to agree with that. I think it's a type of intelligence, but I don't think it's intelligence, but I don't think it's actually intelligent. And I wonder what you think when you reflect on all of this hype and everything that's happened in the last less than a year. What's the world missing about this march towards actual artificial intelligence, or in fact, what you're now working on, which is artificial general intelligence?
As you said, the world has been, the media and the general world has been very influenced by the arrival of large language models, but I have not been. And so what strikes me is just how different the reactions of the public can be, and the reactions of a researcher who's thought about the mind for a long time. For me, it doesn't really change any of the fundamental problems. Large language models. I'm not unaffected, but it does break grounds in the fluidity with which machines can work with language. That has been changed. And if you see language as critical, then you might see this increasing fluidity of machines' use of language as a critical thing. But for myself, I've always been interested in action and not language use. So I always say you will know if a machine is intelligent by the actions that it takes, not by the words. And words are actions, but the language models, they don't know anything about the world. I mean, they don't know anything about space or objects or causality or really about people. It can talk about all those things, but it doesn't really know. And so there's an important sense in which its knowledge, it's apparent knowledge, its ability to mimic people is superficial and thin, and you should not take it seriously. So what happens, and this is a known effect, that people are very influenced by things that talk. You can find it in Wikipedia if you look up the ELIZA effect. It's a reference to a program that came out, I think it was 1965, and it used language, and people were enormously influenced by it. They decided that this thing, understood them and they could have a conversation with it. And this was 1960, so it was like, 12 orders of magnitude ago in terms of computational power. And so, but even with weak computational powers, people were extraordinarily influenced by this fake language user pretending to have knowledge and pretending to understand them. The Eliza was actually pretended to be a psychiatrist. So would talk to people about their lives, say, well, yeah, how do you feel about your mother? And why are you upset by this happening rather than that happening? And people very easily fooled into thinking that the machine understood them. And it was just because it was using language. And when you use language, usually the users of language do understand things.
And the current second highest earning AI application is a company called Character AI, which has created multiple personas that are interacting with millions of people around the world on a fee-for-service basis. And that is second only to OpenAI and ChatGPT for monthly or annual revenue, which I think that's like Eliza on steroids. And you can talk to any persona that you want, but it's still a chatbot.
Yeah. Okay, Lynn, you've got a question or a comment.
Hi, Rich. It's been a long
Hello,
time.
Lynn. Yeah.
I'm not speaking for the government, although I do work for the federal government, NRC IRAP. Actually, if you want, I will get to a question, but I actually want to share my screen and with you all. This is still a work in progress, but we were, NRC and IRAP, we have AI special interest groups. We're getting asked questions about generative AI and large language models and other kinds of models, all of the above. It's pretty hot right now, definitely. But what we were, this, as I say, still a work in progress, but we did some scenario forecasting about, what are the two biggest determinants of what's going to happen or how generative AI is going to impact society and humanity. And I just thought I'd share this with you because we were talking about some of this. And on one axis is, do we get to completely autonomous superhuman generative AI, whatever that is, whatever term you want to use for that, or is it just possibly limited use cases and what it's like now? So that's axis number one. And the other axis is, does it become highly regulated or no regulations? And what do these four different scenarios look like for humanity? And we are seeing, and what are the signals that are going to show us which direction we're going in? And I would say it's sort of true. If it's limited capabilities and highly regulated, this is not particularly creative over here. And where we might be now is limited capabilities and limited, emerging guidelines, but not regulations. Anyways, we'll be our special interest group is going to be monitoring this over time and see where we're heading, or just track it over time. So I thought I'd just share that because it's apropos of some of the things that we were talking about. I'm going to stop this share and I'm going to then get to my question. We are out there trying to educate people about what AI is and what it isn't, and we like to simplify things as much as we can. And so this is what we're talking about in general with AI models. So you do the training, you create, use some magic algorithm or whatever, reinforcement learning or whatever. And you end up with a model that is somewhat fixed. And then, then you run it essentially. So my question actually for Rich is, if you were going to take reinforcement learning I'm paraphrasing you, but your ML model is like just continually learning and it's just continually living and learning. So the question is, how would you draw this picture?
So first of all, you're exactly right that is the picture you've drawn is the standard model that applies to almost all machine learning systems.
And I'm going to unshare while you talk.
That currently exist. And you're also right that my view is totally unlike that. I think my view is not, is easier to understand, frankly. My view is that, you know, an AI system should be like a person, should be like an animal. You don't, you know, you're trying to live your life, or you're a squirrel trying to live in the outdoors, or a coyote. You don't have a separate training phase and a behaving phase. You know, you just have your life, and you do things, and they have successes and lack of successes. Good things and bad things happen, and you learn from it, and you improve. So that should, you know, I always think that my notion of learning is the normal one. Okay, but because the picture that you've painted has become dominant in machine learning. Machine learning is something that happens before you encounter the world. It's just so weird. Those systems, those standard systems, are not learning systems. What they are is they are learned systems. They are learned, but once they're out in the world, they are no longer they are no longer learning. So they're not, I would say they're not learning systems at all. They are learned systems, past tense.
Can you someday draw your picture? So I understand how you
so
you know, I think I understand that, you know, you've got humans got a brain, or reinforced learning system has a digital brain, and it's continually learning.
One thing we've got to incorporate into all of this is that the brain is not simply an organ of logic. There is an emotional element of the brain as well. It plays a critical role in helping to filter what is viewed as attention getting or not. So the models that I've seen are a little bit too linear for my taking in the long haul.
Well, the picture for a reinforcement learning agent or for a person is we receive input, sensations, and then we take action, which we do motor output, influencing the world. But those two are not enough. You need a third arrow in the box diagram, or if you have, you know, the agent in the middle, things got to come into it, things got to come out of it. And then one thing additional, you need a purpose, you need a goal. Okay, and this also brings in emotion. So in reinforcement learning, the third thing is the reward signal. The agent, in addition to having input, sensation, output, motor outputs, its muscle twitches, it also has to receive a scalar, which just means a single number over time. That's called the reward. And the goal of the agent is to maximize the value of that scalar, maximize it over time, right? It has a different numerical value at each point in time, and you want to get a lot of that reward. And that reward would also be pain. Pain would be a negative part of the reward, or a low aspect to the reward. Okay, so if you got input, output, a reward, then that's your box diagram, and your agent does well if it manages to get the reward coming from the world to be high over time. And then in order to do this, the agent has to build up predictions of upcoming reward. Because when you make a choice, you don't really want the choice that gets you high reward in the short term. You need the reward the action that will get you the high reward in the long term. So when you play chess, you may make a move, you may sacrifice a pawn, but you're doing it to win the game in the long run. And so what you need to do is build up a sense of how well things are going. And this sense of how well things are going, it's called the value function. And this is what gives you things that are like emotions, because your values can go up and down. Your rewards might all be zero, just as in the chess game, the reward comes at the end of the game. But during the game, you know, your probability of winning, your estimated probability of winning goes up and down. And those are emotions that you're saying, oh, I thought I was doing good, and now it looks like I'm doing bad. And so that was something went wrong. I maybe must have made the wrong move. I feel bad about that. I will change it so that I don't make that same move again the next time that situation arises. So it all comes from having a goal, and the notion of emotions come from having a goal. And all of these things are absent from the language models. They have no goals. They have no possibility of emotion. You can't say that they're trying to do anything because they're not trying. They're not going to change their behavior based on any outcome.
One of the points that we've
you.
been discussing along these lines is that whether the AI of the future will in fact always reflect a moral compass based on human values, because it's been built by humans based on human history and human perspective. Can it ever be anything else? And that was what was comforting, was the belief that the AI will always have an appreciation and respect for its origins, which is it's been built by humans.
Well, let me be provocative, okay? So let me just propose that maybe we have to, maybe I'll just reject this idea that there are human values. And really, there are. I have values. You have values. Like, I really like chocolate ice cream. Maybe you don't like chocolate at all, and so there's no value there. Maybe I value my children, okay? But you may value your children, and I may also think it'd be great if your children should do well. But I really care about my children. So I mean, it's not so much that we have the same values as much as we have symmetrical values. I care about my food. I care about my children. You really care about your food and your children. And you care about, as I said, we do care about each other's things, but much less. And so, and then there are other things that we may actually just disagree about. You know, maybe I believe that we should our country should have a large army. Maybe you think our country should have a small army. And, you know, people do disagree. And so what would we mean by human values? Well, maybe we mean, you know, values that the majority of the people share. Okay, but that's a pretty weak idea. And you should, it's sort of a misrepresentation to call them human values. That's just, you know, okay, there's a current majority for that idea. It doesn't have any fundamental humanity about it. You know, we used to all agree about many racist things. Okay, and now maybe we try to be less racist. So just because people have a commonality between their value judgments at any point in time, I have to reject the idea of human values.
Okay. I'm going to switch gears a little bit here and ask you, let's talk about education in the future. I mean, you know, we've been putting kids in a classroom of 30. We moved away from the tutoring model of one-on-one, and we've said that as a society, we will engage in the public education, part of which is to civilize you as a member of our society, and the other is to impart upon you learning and giving you you know, the 3 R's. Is that model the model for the future, given that we now have AI that can do an awful lot of what once was expected for you to memorize?
Well, there will be some changes. We do, as even now, we prioritize different things. We used to prioritize, you know, memorizing long written passages, and we used to prioritize doing arithmetic, and those things can be more easily done by machines, and they're not so important. And I think I don't see any great danger from that. Education and learning is still really, really important, and we will need to keep doing it. And there's a lot of reasons to think artificial intelligence can help with that. Like, it can help tutor us in automatic ways, and get kids up to speed at both at knowing stuff and having the abilities to learn more much more quickly than our current educational system.
We'll turn now to Edmonton and your Alberta Plan. So before asking you to give us some background on the Alberta Plan, its origins, you're pretty pumped about Edmonton being a place that is in fact a shining light. We up in the hinterland don't necessarily see ourselves in a global context that way. Share with me your positive perspective of Edmonton. Why you feel so high about it? Just because you're here? Is that a lot of ego?
Well, of course, as Canadians and Albertans, we don't want to be too full of ourselves, and we don't like to brag. But it's also important for us to see what's true as clearly as possible, and that's really why we don't like to brag, because it being arrogant, it just gets in the way of seeing the truth. So what is the truth? Well, I think that one aspect of the truth is that Edmonton is the world leader in the reinforcement learning approach to artificial intelligence. And maybe it's because all the other major universities throughout the world have paid short shrift to reinforcement learning. But for whatever reason, I feel regret about this, but for whatever reason, Edmonton is the center of reinforcement learning in the world. We have at least 10 faculty members of the university whose research is centered on reinforcement learning. And you won't find any place else in the world that comes close to that. Okay, so maybe that's just a mistake that we're all making, but it's a specialty that we have. And then I have to say that I, as one of those 10, I happen to think that reinforcement learning is the most important approach to artificial intelligence. So I'm thinking it's the reason I'm pursuing it is because I think it's the most important and most likely to be successful to bring us through AI. So I can't help it. I'm stuck in this mode. I have to be arrogant. I have to say, well, I happen to believe this is the best way, and it's objectively true that Edmonton is the place that is most exploring this way. So if you put those two things, I have to believe that Edmonton is actually the world leader in artificial intelligence. Okay, so I hope I've explained that so you'll forgive me for saying such an arrogant thing, and I do feel regret about saying such an arrogant thing. But it's interesting; it does seem to follow from the facts and my beliefs. So
I'm going to ask you.
You've gotten here to hear what I think.
Well, I'm going to ask you to clarify. I'm going to ask you to clarify what Edmonton. I heard you describe 10 faculty members. They're sitting in the ivory tower with a river between them and the city. Is it Edmonton you're talking about, or just the university? We've got Amy. We have Bridges, but do we have
Amy in the university is where these. So AI is mostly an academic. It's an unsolved problem. I mean, you may consider AI is amongst us. What does AI mean? If AI means a particular technology like ChatGPT or supervised learning or spam filters and recommendation systems, all those things, no, those are not reinforcement learning, and they're I might want to not call them intelligence. They are certainly the use of computation to do things that are hard to do and valuable to do. But they're not interacting with the world and figuring out the best way to interact to achieve your goals. Okay, so that topic, let's go ahead and call it reinforcement learning. That topic is an academic topic still. It's not. It has a few applications. People use it for place ads on the internet. People use it as part of large language models. People use it to do algorithmic trading on the markets. There are applications, but mostly the full general sense of reinforcement learning as an approach to artificial intelligence is still an academic topic. It's still a topic for universities and not for industry.
Okay, well, we're going to keep our eyes on whether or not it's porous or not, and whether or not there's an opportunity for us to do more pulling, or you may do more pushing. Okay, the Alberta Plan. Some of us have actually looked at the video where you've described it. It's a little hard for some of us neophytes to fully understand, but if you could, for 8th graders, explain, so what is the Alberta Plan? Why? And what's the mission? If it's going to help us achieve make the greatest achievement in mankind, it's worth talking about. So tell us about it. And what is this plan?
Well, first of all, it's a document. It was written by myself and Michael Bowling and Patrick Pilarski. And it's basically a reinforcement learning approach to AI. So it says AI, intelligence, it should be about the interaction between an agent and its environment to achieve a goal. It should learn and do everything that it does, whether it's including its learning, including its planning, everything that it does, it should do continually in a temporally uniform manner. That means you should not have phases Like classically, as Lynn was explaining, in supervised learning, they have the learning phase and they have the acting phase. Well, one of the principles of the Alberta Plan is there are no phases. Anything that the agent does, it should do at all of its times. There's 4 principles. Those are 2 of them: temporal uniformity and experience oriented. The third one is we are concerned with computational cost. Often researchers will ignore the computational costs. We think computational costs are very important. And maybe the 4th one, if I'm remembering correctly, is that we view the world as big, really big, much bigger than the agent. And because the world is much bigger than the agent's understanding of the world is always going to be imperfect. So why is the world much bigger than the agent? Because agents can be pretty big now. The agent is the AI. And computers can be pretty big nowadays, but still the world is much, much bigger than any agent. Partly because the world is so immense and includes all the atoms in the universe, but also because the world includes other agents. And that is a particularly prominent part of the world. Like we all care about what other people think. And like you go to the job, you want to impress your boss, or you're interacting with your spouse, and you are very much concerned with what's going on inside their minds. And so you can never understand fully what's going on in their mind. You've never put in your mind a representation of what's going on in all those other people's minds. For every practical point of view, the world is infinitely complex, and your understanding it is always going to be imperfect. So those 4 principles, starting from those 4 principles, we then lay out a 12-point process, or 12 steps to make an AI agent or a prototype AI. And so the body of the plan is those 12 steps that are ultimately are about things like continual learning and meta learning and integrating planning with learning, and then also ultimately integrating AI with IA being intelligence augmentation, where we augment the intelligence of people with the AI. That's the outline of the Alberta Plan.
So the vehicle.
Why do we call it the Alberta Plan? I mean, it seems to be the plan that has emerged out of Alberta. We don't have the official permission of the province of Alberta to call it Alberta Plan. We just went ahead and did it. It's not the official plan of the University of Alberta. It's a plan of us 3. But we think it's representative of a distinctively Albertan point of view on artificial intelligence, as I suggested earlier.
So if this plan is in fact reflective of intelligence, there must be actionable goals. What are the goals?
Well, the goals are mainly sort of at a more technical level than you're probably going to find useful.
Okay, well, let's back up.
But let me describe just one, which is I think quite accessible and is interesting way. So we described earlier the way modern machine learning systems are systems, but they're more learned systems. They don't continue to learn. And so this is an absolute and very important thing, but you might think that it could be changed. Why can't we overcome this of current machine learned systems that they can't continue to learn? And so that is the first goal, and I think it's pretty measurable, that we can change and make a new generation of neural networks, artificial neural networks, that are capable of continuing to be updated after they're installed and living in the world. So, and the buzzword is continual learning.
Right. And the instrument, is it an institute? Is it a club? Is it a faculty? What's the instrument for achieving this goal?
So there are more than the 3 people that pursue it. We're pursuing it at the university in our research groups. We are also pursuing it. I'm pursuing it also in a startup called Keen Technologies, where I'm actually working the majority time. It's just a small startup of 5 people. sprinkled in Edmonton and Texas and Switzerland. And in addition, we've introduced a new grouping in Edmonton called the Open Mind Research Institute. The Open Mind Research Institute is explicitly separate from the university and explicitly devoted to doing research in a totally openly published manner, with no intellectual property held private, but everything available to the world.
Well, we're getting to the
Cool.
finish line. Jeff, you've got a point you want to make?
I was just going to pick up on what you mentioned about Keen Technologies, and it was a question I was going to ask you because I read a fascinating article some months back, an interview with John Carmack, who is the top guy at Keen
Founder.
Technologies. The founder, and I didn't realize you were now a part of that entity. But
I am now his partner.
Right. I think that's wonderful. I mean, as much of a legend as you are in artificial intelligence, John Carmack is a legend as well in computing. He was at Meta. He's, in terms of first person gaming, like this guy is brilliant. And he said some things in that article about, believing that AGI is not going to be something that is coded or created by this giant team at a massive company. It's going to be put together by a small group of people, and it's going to be a surprisingly small number of lines of code, which I think is just mind-bending. And I was so thrilled to see the collaboration with John Carmack and yourself and Amy announced, because I just think the world of him and of you as well. And I think that demonstrates what you were getting at in terms of the 10 faculty here at the University of Alberta. Edmonton and the U of A is a hub. It's a magnet for talent. And when you have a guy like John Carmack from Dallas, Texas, coming here and collaborating and partnering with you, I think that's a tremendous sign. And I think you're being too modest when you talk about reinforcement learning. You literally wrote the book on reinforcement learning, and all of the stuff that we're now regularly blown away by with all of this hype around AI, all of that is only possible because of the use of reinforcement learning. And it's not the only thing, of course. There's transformers and all of that, but reinforcement learning is so critical to that. And so for you to say that's your bias and that's where you see this going, I think I understand that bias, and I think I'm thrilled that you're here and that it's such a focus of the University of Alberta and now Keen Technologies, and I wish you guys all the best.
Thank you much. Thank you very much, Jeff. I also read that article, the interview with John Carmack, and I would encourage people to check it out because I read it and I just agreed with it so much, and yet it was so contrarian. It was not the normal view, but it was agreeing. I was very sympathized with it very much, and so that by reading that caused me to contact John and eventually team up with him.
Go ahead, Mel.
I just got one question that's hypothetical, probably borders on reality, but if we go back to the first principles of training an AI, where it goes out there and essentially looks at billions and billions of items of data and brings it all in, puts it all together, and does its probability, statistics, etc. on it, creates all its tokens and all that type of stuff. And then we get to a point where we turn this AI loose on the internet after it's been established a little bit. And as you said earlier, you train it, and if you don't expose it to anything else, it really doesn't get any smarter. It just works with what it has. But now if we turn this loose on the internet, where it goes out like a web crawler and brings in everything every day that changes, and billions of pieces of information, and it uses that as extended training. As the time goes on from its initial training, there's going to be more information coming back into it, where people will have used the AI to get responses to their questions, their queries, and then they'll take that and put their own interpretation on it and republish it, because everybody now is a social media expert. So now there's a bunch of fake information, not so clean, that type of stuff, incomplete, contradictory, and that type of stuff. if I was to study a subject and then, knew it really well, and then I saw something on the internet or somebody told me something about that subject that wasn't quite right, I would be able to detect it pretty quickly because maybe I've got some experience, which the AIs don't have because they're not human. So how do we propose to get around making sure that what the AIs provide to us is really, let me use the word, clean information, correct information?
I think it's a big problem. I think it's a very big problem. And it's not clear that there is any solution possible. Those systems don't have any way of, they don't have a sense of truth.
Exactly.
And so they cannot verify.
Thanks, Mel. Always like having an upbeat question as we wrap up the webinar. In any case, Rich, I think this is the first question I asked you was to reflect on your foundation in the humanities. I have always felt that the real creativity and innovation in a university will come on an interdepartmental basis, and that we should do more to see how the humanities and engineering might work together. Maybe not as a core, as a foundation. So those that have the engineering tools also have I'm using the word values, whatever values are part of that career. But I think you're an illustration of the creativity that comes from understanding the humanness and building machines that are of use for those humans and will advance our society as a byproduct. So I'm crediting you, but I'm also crediting the foundation on which you've been built, and wish more would think that way, and that universities would be maybe rethinking the foundations of their degrees.
General liberal arts education. It's a very
Hang
good
on.
foundation.
Yeah. And some people think it's an escape. It's a cop-out, but I couldn't disagree more. Claire, thank you. David, thanks for joining us. Tommy from Prince Edward Island, Mel down in Cochrane, Bogdan, Jeff, Richard, this was superb. I'm not at all disappointed with the mess up in the recording, because I think this was richer. And I thank you very, very much. Jeff, for your insights as well. Tom, Lorenz, good to see you. And Yogi and Greg. So thank you again. We look forward to seeing you and maybe one of your colleagues in a future webinar. So thank you all. Good night.